Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on electric field from March 2021, Paper 4, Variant 2. In this question, we will discuss some very important concepts about electric field. And those concepts are very important to understand this topic and to answer similar type of questions in exam. For part A, we need to state a similarity between the gravitational field lines around a point mass and the electric field lines around a point charge. First of all, let's try to sketch gravitational field around a point mass. Let's say this is over point mass. Point mass means that it has no size. If we need to draw the gravitational field around this point mass, we need to draw field lines pointing towards this mass because gravitational force is always attractive. It simply means that if we place a test mass here, this mass will be attracted towards this point mass. We can draw some more gravitational field lines. So this is how we can draw the gravitational field around this point mass. So this is gravitational field. So if you look at the shape of this one, this field is radial. So this is radial field, or we can say radial field lines because the field lines are along radius. So we can say these are radial field lines. Now imagine that we have a positive point charge. In this case, if we need to draw electric field lines, we have to draw these field lines pointing away from this charge. So this is how we can draw the field lines if the charge is positive. So we can draw some more field lines. So you can see the clear shape of this electric field. So this field around this point charge, this is radial field, or we can say these lines are radial field lines. So this is the similarity between these two fields. We can also draw for negative point charge. So if we have a negative point charge, so let's say this is our negative point charge and these are field lines around this negative point charge. In this case, we have to draw field lines pointing towards this negative charge because in this case, if we place a positive test charge here, force on this one will be attractive like gravitational force. So we have to draw field, these arrows pointing towards this point charge, very similar to the gravitational field. So we have to draw arrows pointing towards point charge. So this field is also radial. So we can say this field is also radial, or we can say the field lines are along radius, so we can say radial field lines. So if you look at similarity, you can see point charge or point mass, they have radial field lines. This is one similarity. So one similarity we can say both have radial field lines. So simply we can say radial field lines. So this is one similarity. We just need to write down one. If you write down one, you will get 1 B mark. This is. But we can also write down another one. But if you look at these fields, we can also say one thing more is similar. If you look at the distance between these lines, you see as the distance is increasing from this point mass, the gap between the lines is increasing. It means the gravitational field is getting weaker. And this is inversely proportional to R square, mean the distance from the point mass. And this field is the same. As you see, we go away from this point charge, the gap between lines is increasing. This is telling us that electric field is also inversely proportional to R square, and R is the distance from any point to the center of this charge. So this distance, this is R. So in this case, this distance is R. As R increase, field get weaker and weaker. So the second thing we can say, both obey inverse square law. So we can say inverse square law. If you want to write down relationship, you can also write down. But if you simply write down inverse square law, that's quite enough. Both obey. So these two things we need to write down, but for this question, you just need one of them. If you write down, you will get 1 mark. By looking at these fields, we can say gravitational force is always attractive. So gravitational force is always attractive. But if you look at this one, in this case, electric force is repulsive. So electric force is repulsive. But if you look at this one, electric force is attractive. So it means electric force can be repulsive, it can be attractive, but gravitational force is always attractive. For part B, it is given to us the variation with radius r of the electric field due to an isolated charged sphere in a vacuum is shown in figure 6.1. Use data from figure 6.1 to state the radius of the sphere. So first thing we need to understand, we have isolated charged sphere. So imagine that this is isolated charged sphere. If we place any charge on the surface of this sphere, that charge will not stay here. This charge will be equally distributed. For example, we have only 2 charges on the surface of this one. Those charges, they will go away from each other as much as possible because like charges, they repel each other. So the only way where they can stay is at the surface and away from each other. If we have 4 charges, they will be distributed somewhat like this. If we have 6, let's say we have 8 charges, they will be distributed like this. Means they will stay at the surface and they will be far away from each other as much as possible. And that is only possible they stay at the surface. So if we look at, imagine that we place one positive charge at the center of the sphere. The net force on this positive charge at the center will be equal to 0. So the net force on the charge at the center will be equal to 0 because forces due to these charges, they will cancel each other. So the net force on charge at the center of the sphere will be 0. So we will simply say charge in this case will not move. Charge inside the sphere will not move. Charge inside will not move because net force on the charge is equal to 0. So we can also say the electric field inside, as net force is 0, so electric field inside the sphere is also 0 if this is conducting sphere. So in this case we have charge sphere, that is conducting sphere. So in electrostatic equilibrium, field inside this sphere will be equal to 0. So the field inside sphere is equal to 0. We can also see this one from this figure. In this case you see electric field up to this point, electric field is equal to 0 and this point is 2.1. So it simply means that the radius of the sphere, this is equal to 2.1. So simply we can write down radius of sphere is equal to 2.1. Let's try to understand a little bit more about this one in a little bit different way. So you can visualize this one. This question is very common in past papers. If you look at given informations, it is given to us the variation with radius r. So it means this one is the radius. So this is the first thing you need to understand. That's the reason we said radius is equal to 2.1 centimeters. We can draw the sphere as well. If I draw the sphere here, you can simply see this one is the sphere. So it is simply telling us r is the radius of the sphere. R you can simply see from here, r is the radius of sphere. So that's the reason we said r is equal to 2.1. So this is value of electric field at the surface of sphere. So we will need this value. So the electric field at surface of sphere is equal to 1.3 times 10 to 5. So we can say at surface, we will need this value for the next part. We will say at surface, electric field is equal to 1.3 times 10 to 5 volts per meter. So this is value of electric field at surface. And after this one is decreasing and this will follow inverse square law. So inside electric field of this sphere is equal to 0. So electric field here is equal to 0. For the second part, we need to calculate the charge on the sphere. On the sphere simply means that at surface of sphere. So simply we can write down, we need to calculate Q at surface. So we can also write down here, this is what we need to calculate, Q at surface. Now if you look at this given graph, we can also sketch the sphere at this point. So this one is the sphere. What question is asking us to calculate, that is charge at surface of sphere, means the charge on the surface of the sphere. Imagine that we have certain amount of charge at the surface of sphere. So we have this amount of charge. This is at the surface, and this is we need to calculate. This is we need to calculate, mean this value of Q. So how we can calculate? First thing we need to understand, at the surface of the sphere, we have value of electric field. So we can say E surface we have, and E surface is equal to 1.3 times 10 to 5 volts per meter. We also understand for a point charge, means for a charged sphere or for a point charge, electric field is equal to Q over 4 pi epsilon naught times 1 over r square. In this case, we need to calculate Q. So we can rearrange this one. So in this case, Q will be equal to 4 pi epsilon naught times r square times E. Now simply we need to plug in values, and this r is the radius, mean the distance from the center of the sphere, and that distance is equal to radius. So simply we need to plug in values, and we can find value of Q, means the Q at surface of this sphere. So in this case, pi is constant, so simply we can say this is 4 pi. Epsilon is constant. You can get value of this one from given values of constants, and this is equal to 8.85 times 10 to negative 12. Radius of sphere we have already found, that was 2.1, or you can simply read from here. This is 2.1, and this is in centimeters, so we have to convert this one into meters, and the square of that, and we need to multiply with electric field. Electric field at the surface is 1.3 times 10 to 5, means this value we have is 10 to 5. Now we just need to simplify, and we can find out final value of Q at surface. So up to 2SF, this is 6.4 times 10 to negative 9 coulombs. So this is value of Q. So our final answer for this question is 6.4 times 10 to negative 9 coulombs. This is how we can calculate charge at surface of sphere. For part C, we need to use the formula for the electric potential due to an isolated point charge, and we need to determine the capacitance of the sphere in P. First of all, let's try to write down electric potential due to isolated point charge. Value of V is equal to Q over 4 pi epsilon naught times 1 over r. So this is the formula for electric potential for an isolated point charge. For this question, we need to calculate capacitance. Capacitance is equal to Q over V. We need to calculate capacitance of isolated charged sphere. So we have to take value of Q at surface of sphere, and we have to take value of V at surface of sphere as well. So C is equal to Q surface over V surface. Now simply we need to plug in value of V, and we need to simplify this one. V is equal to Q over 4 pi epsilon naught times R. So if we simplify this, we can say this is equal to Q over Q times 4 pi epsilon naught times R. So this Q we can cancel with this Q. So simply C is equal to 4 pi epsilon naught times r, and r is the radius of sphere. So if the radius of the sphere is greater, it means the capacitance of sphere is greater. Simply means that sphere can store more charge. Now we need to plug in values. We need to calculate value of C. C is equal to 4 pi epsilon naught times R. You also need to understand how to derive this formula. Sometimes they will simply ask you to derive this one. So the derivation of C is also important for your exam. Now simply we need to plug in values. 4 pi is constant. Epsilon naught is 8.85. times 10 to negative 12. R is the radius of sphere. So R is the radius because we are talking about charge at surface of sphere. So R is the radius. So let me redraw this here. So in this case, we are talking about charge at the surface. So R is the radius. So R is this radius. And value of R we have already found, that was equal to 2.1 centimeters. So we have to convert this one into meters. Now if we simplify this, we can get final answer for C. That will be equal to 2.34 times 10 to negative 12 in farads. So this is our final answer, 2.34 times 10 to negative 12. So this is how we can answer this question. Very common question in past papers. So you need to understand how to answer this type of problem.